Okay, welcome back. In this video, we are going to look at the connection between the hypothalamus and the pituitary. So in the top here, you see it says hypothalamus, and then down below it, right in the center, you see in those two red boxes, anterior lobe of the pituitary on the left-hand side, and on the right in that red box, you see it says posterior lobe of the pituitary gland. The anterior lobe is the adenohypophysis, posterior lobe is the neurohypophysis. On the upper right, you could see that there's a key to the pituitary hormones. So ACTH is adrenocorticotropic hormone, TSH, thyroid stimulating hormone, GH is growth hormone, PRL is prolactin, or prolactin releasing hormone, FSH, follicular stimulating hormone, LH, luteinizing hormone, MSH, melanocyte stimulating hormone, ADH, antidiuretic hormone, and OXT for oxytocin. Now, what I want you to see on that left-hand side, we'll kind of start with the ACTH, where the anterior pituitary is releasing ACTH, adrenocorticotropic hormone. Now, adrenocorticotropic hormone is going to go to the adrenal gland. Now, when you look at the adrenal gland, you'll see that there's an outer portion and an inner portion. The inner portion is called the adrenal medulla. The outer portion is called the adrenal cortex. So when you look at the name of the hormone, ACTH, adrenocorticotropic hormone, it tells us that it's going to go to the adrenal cortex. Okay, what does the adrenal cortex release? If we follow that purple arrow down, it releases glucocorticoids. There's the word cortico again. And gluco refers to glucose. So glucocorticoids are going to find a way to affect and increase blood sugar. The biggie is being cortisol. Cortisol, corticosterone, corticosteroids, right? So cortisol is a biggie. Cortisol is released when you're under a lot of stress. It's kind of like an anti-stress hormone. It helps you deal with stress. But cortisol, its impact is that it can increase your blood sugar, and it can increase your heart rate, and it can increase your blood pressure, and it can increase your cholesterol. Isn't it interesting? Haven't you heard that stress can kill? Well, it's one thing to have the adrenal gland stimulated for a short period of time in an acute state, but what if it's stimulated chronically for a long period of time? Now you have high blood sugar for a long period of time, high cholesterol for a long period of time, high blood pressure for a long period of time. You get high sugar, high blood pressure, high cholesterol. That's a combination that kills. Okay, so that's the adrenal cortex. On the inside is the adrenal medulla, but that has direct connections from the neural system. Right on the top left, you see direct control by the nervous system. There are these fibers that lead right into the adrenal medulla. And the adrenal medulla releases norepinephrine and epinephrine. You see that in that blue circle there on the left. Epinephrine is adrenaline, norepinephrine is noradrenaline. That's also involved in the stress response. Okay, we'll go into this a little bit deeper about acute stress and chronic stress when I cover just the adrenals by itself. Okay, if we look at the next connection at the anterior lobe, now we have TSH, thyroid stimulating hormone. You could see thyroid stimulating hormone going to the receptors on the thyroid gland. The thyroid gland is going to push out T4, thyroxine, and a little bit of T3, triiodothyronine. However, the majority of T3 is actually released by the liver. T4 can be converted into T3 in the presence of selenium. So having good functional liver is really important for good metabolism and for healthy T3 function. All right, what do we have next? Growth hormone. So growth hormone is going to be released by the anterior lobe. It's going to go to the liver. The liver releases somatomedins, and that's going to help with regeneration and growth of muscles, tendons, ligaments, bones. Growth hormone is released primarily when we sleep, which is why it's so important to take these naps throughout the daytime. We know professional athletes take naps for that extra burst of growth hormone. We know babies are napping all the time because they push out growth hormone, and babies do grow quickly, right? So growth hormone is really important. Prolactin. So the anterior lobe releases prolactin. It goes to the mammary glands, and women can produce milk through the mammary glands and mammary ducts. Now we have this crosstalk of FSH and LH, follicular stimulating hormone and luteinizing hormone. These two hormones affect both male and female reproductive. It is going to affect the testes, and it is going to help with the production of testosterone. And it also affects the ovaries in women to help with estrogen production and progesterone production. Then there's melanocyte stimulating hormone that helps to affect the color of the skin. There's still a lot of research going on with melanocyte stimulating hormone, but what we know right now is that it is involved with skin pigmentation. When we look more in the posterior lobe, the neurohypophysis, we have oxytocin. Oxytocin is known to affect the female uterus, the smooth muscle, the endometrium, the myometrium, and then the epimetrium. Those are the three layers of the uterus. The oxytocin is going to affect the smooth muscle layer called the myometrium. It's going to make it contract. That's when women experience cramping during their menses or the contractions of labor. That's oxytocin. Oxytocin affects the male reproductive as well at the vas deferens or the ductus deferens. It makes it contract during ejaculation. And finally, in the posterior lobe, we have ADH, antidiuretic hormone. We know what a diuretic is, right? Alcohol is a diuretic. Coffee is a diuretic. We know those things make people pee or urinate. So an antidiuretic is going to hold on to water. Now keep in mind, general rule of thumb for simplicity, if you're losing water, you're going to lose minerals with it. And if you hold on to water, you retain minerals. If you eat potato chips or salty pretzels that are high in sodium, you want to drink water. Salt and water go together. If you lose too much water, you're going to lose minerals and salt and sodium with it. So just keep that general concept in mind. When you lose water, you're going to lose minerals. When you hold on to water, you save minerals. Again, when we look on the top left here, we see growth hormone. It's going to target the liver, and it's going to stimulate the liver, muscle, cartilage, bone, and other tissues to synthesize and secrete these insulin-like growth factors, which in turn, they're going to promote growth of the bodily tissues. Okay. When you look at TSH, thyroid stimulating hormone, it's going to stimulate the synthesis and secretion of thyroid hormones by the thyroid gland, T4 and T3. When you think of FSH, follicular stimulating hormone, it's going to affect the testes and the ovaries to produce sex hormones, as is LH, luteinizing hormone. Luteinizing hormone is a biggie, especially for women when they're trying to plan a pregnancy. It's the LH hormone that's being monitored through those like urinary dipsticks. When luteinizing hormone spikes, that's when a woman is ovulating. When a woman ovulates, that's when the ovary pushes out a mature egg. And the fimbriae, those little fingers of the fallopian tubes, it's gonna scoop up that egg that the ovary pushed out. And that window is like a 24-hour window. It's very small. And that's really the only time that pregnancy can happen is when the ovary releases the egg and it's hanging out of the fallopian tubes or the uterine tubes. And when sperm meet up with that egg, it can fertilize it. Okay, so fertilization should take place in the fallopian tube or uterine tube, and then the cilia beat rhythmically to move that fertilized egg into the uterus, where implantation should take place. If implantation takes place in the uterine tube or the fallopian tube, that's called an ectopic pregnancy. We want it to happen in the uterus. Prolactin is going to be prolactation. It's for milk production. And then on the bottom left, you can see the adrenal gland or the adrenal cortex. The adrenal cortex is going to push out glucocorticoids and mineral corticoids. Glucocorticoids like cortisol, corticosterone, and mineral corticoids, especially aldosterone. That's a very, very important mineral corticoid, aldosterone. Aldosterone regulates sodium balance, sodium and potassium balance. And then we have melanocyte stimulating hormone. On the posterior pituitary side, there's your oxytocin and ADH. Okay. Let's put a pause here. When I come back, I'll talk about homeostasis with positive and negative feedback loops.